Good evening, everyone. Thank you so much for joining us. My name is Rosemary Holt, and on behalf of the Catholic Information Center and our director, Father Charles Shulos, it is my pleasure to welcome everyone who is joining us tonight here in person and online, and to introduce our speaker, Professor Stephen Barr, President of the Society of Catholic Scientists. Stephen is a professor in the Department of Physics and Astronomy at the University of Delaware and director of the university's Barr Research Institute. The Barr Research Institute's function is to carry out the forefront of scientific research with a primary focus in physics, astronomy, and space sciences. Professor Barr does research in theoretical particle physics, especially grand unified theories, theories of CP violation, neutrino oscillations, and particle cosmology. He's a fellow of the American Physical Society and author of Modern Physics and Ancient Faith. He was awarded the Benin-Martini Medal in 2007 by Pope Benedict XVI for service to the Church. He has written for First Things, National Review, The Weekly Standard, and Modern Age, among others. Professor Barr has lectured in more than 23 states on the relation of science and religion. Tonight, Professor Barr will discuss this unique relationship between science and faith and dispel the myth that the two cannot live in harmony. And with that, please join me in welcoming Professor Stephen Barr.
Thank you, Rosemary, and thank you, Father Triols, and thank you for coming out to hear me this evening. So, before I start, I want to ask you how many of you know who that clerical gentleman standing next to Einstein is. Raise your hand. Okay, well, if you learn one thing tonight, it'll be that. So many people think that there's a conflict between science and religion, and you obviously must know that, otherwise you wouldn't be out here this evening. When people hear that I am a Catholic and a scientist, they often ask whether I have any difficulty reconciling the two. And I've always found that a strange question, because the same things, or many of the same things that make me a scientist, make me a Catholic. A sense of wonder about the world, a desire to understand the reasons for things, and a belief that everything holds together in some coherent way. For me, and for many of my Catholic scientist friends, the Catholic faith and science are both ways of making sense of the world. Now, science, the natural sciences, tell you about the things that you can sense and measure. But the Catholic faith has a much broader scope. It answers much deeper questions. Questions about the ultimate cause of existence. Questions of our ultimate destiny. About God and man, about truth and love, about sin and redemption, and good and evil. So it is a broader perspective. Science and the Catholic faith are two different perspectives on reality. They're different, but they're not in conflict. I've been a scientist for over 40 years and a Catholic for 64 years, and I am aware of no scientific fact that contradicts any teaching of the Church. So why do so many people think there is a conflict between science and religion? One reason is that people lump all religion together. So any superstitious or magical practice they come across, they regard as evidence of the irrationality of all religion. And many fail to see the distinction between science itself and a certain philosophy that is often called scientific materialism. So what is scientific materialism? Materialism is the idea that all reality is reducible to matter and its behavior. Scientific materialists are people who think that this view somehow necessarily flows out of the findings or is implied by modern science. It is an opinion that is held by many scientists and by many people who claim to speak in the name of science. But it has no claim to being science. It is, as I said, just a philosophical opinion. Now, if matter were the only reality, then of course God would not exist because God is not material. But neither would human spiritual souls exist. A human being would be nothing more than a complex structure made of atoms. And everything about a human being would be ultimately explicable in terms of how those atoms move and the laws of physics that govern how those atoms move. In other words, scientific materialism doesn't just imply that God does not exist. It also implies that in a certain sense, you don't exist either. The popular astronomer and science writer Carl Sagan put it this way: I am a collection of water, calcium, and organic molecules called Carl Sagan. And Francis Crick, co-discoverer of DNA, said, or wrote, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. As Lewis Carroll's Alice might have phrased it, you're nothing but a pack of neurons. Now, for some of its adherents, it is just a philosophical opinion, but for others, it's a passionately held ideology that has a saving mission. And that mission is to free the human mind from irrationality and superstition, among which they count religion. So for such people, it's not enough that science brings us understanding of the world and brings us many other benefits. There must be an enemy to be vanquished, and they cast religion in that role. This accounts for the strange zeal that some materialists, like Richard Dawkins, have in propagating their ideas. They feel they are taking part in a grand struggle between reason and its enemies. Now, scientific materialists have a well-developed critique of religion, which has at least three aspects: they're philosophical, historical, and scientific. Their philosophical claim is that there is an inherent contradiction between the scientific and religious outlooks, apart from anything science may have discovered. Science is based on reason and evidence, whereas religion, they say, is irrational, because it is based on dogma, faith, and mystery, which involve belief in things that cannot be seen and for which, supposedly, there is no evidence. Science is based on natural explanations and natural laws, whereas religion is based on miracles and the supernatural. They see religion as a matter of myth and magic, and therefore the antithesis of a rational scientific outlook. Their historical claim is that religious believers and institutions have historically been hostile to science and tried to suppress it. This is powerfully symbolized in the eyes of many people by the Church's treatment of Galileo 400 years ago. And this impression is constantly being reinforced in the public mind by the never-ending battle against evolution waged by fundamentalist Protestants primarily. The materialist scientific claim is that the actual discoveries of modern science over the last 400 years have debunked or undermined basic Christian beliefs about the universe and humanity's place in it. As the story is often told, science has dealt one blow after another to the religious conception of the world. Copernicus showed that humanity is not at the center of the universe. Newtonian physics showed that the universe is governed by blind and impersonal forces and is purely mechanical. Modern astronomy showed how small and insignificant we seem to be when compared to the cosmos as a whole. Darwin, some say, showed that human life is an accident and that human beings differ only in degree and not in kind from lower animals. Advances in neuroscience and artificial intelligence are thought to be demonstrating that the supposed soul is nothing but the workings of a complex biochemical computer. And modern cosmology is invoked to show either that the universe had no beginning or that the universe created itself out of nothing by a quantum fluctuation. Now, in this talk, I'm going to focus primarily on the materialist philosophical and historical claim that religion and Christianity in particular are inherently contrary to science and historically have been its enemies. In the last part, I will, if I have time, discuss some of the things modern physics has discovered and argue that they are more consonant with what Catholics believe than with materialism and atheism. Now, I may not get to much of the physics, but I welcome questions at the end about the physics. So let me begin with the supposed opposition between the supernaturalism of religion and the naturalism of science. Christianity and Judaism were never based on supernaturalism. If you mean by that the rejection of the idea that there's a natural order. In fact, scholars tell us that the book of Genesis was, in part, a polemic against the supernaturalism and superstition of ancient pagan religion. When Genesis said that the sun and moon were merely lamps placed by God in the heavens to light the day and the night, it was countering the paganism in which the sun and the moon were worshipped as gods. When it said that man is made in the image of God and is to exercise dominion over the animals, Genesis was, among other things, attacking the paganism in which men bowed down to animals or worshipped gods made in the image of animals. In paganism, the world was imbued by occult forces and inhabited by countless deities, gods and goddesses of the oceans and forest, of the wind and fire and lightning, of sex and fertility, and so on. Jews and Christians, however, taught that there is just one God who is not to be found in the phenomena and forces of nature, but a God who is outside of nature, and indeed who is the author of nature. In this way, biblical religion stripped the physical world, or the physical universe, of divinity and made it into a natural world, no longer the abode of gods, but the creation of God. And since God is good, the natural world was seen as something good and worth studying. And since God is intelligent and wise, he made the world in such a way that according to principles and laws that are discoverable by reason and can be understood by reason. Biblical religion, then, taught that there is a natural order which comes from God. And what characterizes this natural order and reflects the wisdom and rationality of its creator is precisely that it is orderly, harmonious, and lawful. So consider this passage from the letter of Clement to the church in Corinth, written around 97 AD. As you know, Clement was the fourth pope. We mention him in the Roman canon. Linus, Cletus, Clement, Sixtus, Cornelius, and so on. It's that Clement. So he wrote in a letter to the Corinthian church, "The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and the starry choirs roll on in harmony at his command, none swerving from his appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony. Or consider this passage from the Latin apologist Minucius Felix, writing around 200 AD. If upon entering some home you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it, and that he was himself much superior to those good things. So too, in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe more beautiful than the stars themselves and the various parts of the whole world. Look what they point to as evidence of God, not to supernatural phenomena or miraculous departures from the order of nature, but to the order of nature itself and its lawfulness. The ancient argument was that if there is a law, there must be a lawgiver. God was the lawgiver not only to Israel, but to the cosmos itself. God says in Jeremiah chapter 33, "When I have no covenant with day and night and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David." Psalm 148 tells of God establishing the sun, the moon, the stars, and the heavens by a decree or law. The idea of God as a rational lawgiver very likely helped give rise to the idea that there are laws of nature. And this is conceded at times even by some atheists. For example, the eminent biologist Edward O. Wilson, the founder of sociobiology, suggested the following as the reason that Chinese civilization, for all of its impressive scientific achievements, did not produce a Newton or a Descartes. Chinese scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed for them. Consequently, the objects they meticulously described did not follow universal principles. In the absence of a compelling need for the notion of general laws, thoughts in the mind of God, so to speak, little or no search was made for them. And the well-known cosmologist André Linde, an atheist, has suggested that the notion of a universe governed by a single law in all its parts is historically rooted in monotheism. Our faith does, of course, teach us that there are supernatural realities and that they have real effects in the world, such as divine grace. But the word supernatural itself, which means above the natural, would make no sense unless there were a natural order to begin with. And the idea of miracles, which are extraordinary events that go beyond the order of nature, presupposes that there is a natural order that defines what is naturally possible and what is not. There is no contradiction logically between the idea of miracles and the idea of a lawful universe. For the same lawgiver who established the laws of nature can suspend them or make exceptions to them for the sake of some greater purpose. And as we shall see, the men who led the development of modern science in its first few centuries, the pioneers in uncovering nature's laws, were virtually all men who were devout Christians and believed in miracles. There is much confusion today among both religious believers and atheists about how nature relates to God. Instead of seeing God as the author of nature, they see God and nature as somehow opposed or in competition with each other. So that if something has a natural explanation, then God has nothing to do with it. And if God is the cause of something, well, then it must be supernatural. This is not at all the traditional Christian understanding. But this understanding has led people to try to prove the existence of God or to look for evidence of God solely in things that are scientifically inexplicable or outside the course of nature. And hence the expression, the God of the gaps. The atheists think by closing those gaps in our scientific understanding, they'll leave no place for God to hide. But the traditional Christian view is very different. If God, as the creator of the natural world, established its laws and gave to things their natural powers, then his existence is evident in nature itself and its ordinary workings. This is the message of the following passage from the Book of Wisdom, which was written around 50 BC, or at least in the 1st century BC, and is part of the Bible, though not recognized as such by Protestants. It's actually the only passage in the Bible that is, in a sense, directed at scientists. It was the scientists of ancient Greece, the scientists, philosophers of ancient Greece. It's chapter 13 of Book of Wisdom. For all people who are ignorant of God were foolish by nature, and they were unable from the good things that are seen to know the one who exists, nor did they recognize the artisan while paying heed to his works. But they supposed that either fire or wind, or swift air, or the circle of the stars, or turbulent water, or the luminaries of heaven, were the gods that rule the world. If through delight in the beauty of these things, people assumed them to be gods, let them know how much better than these is their Lord, for the author of beauty created them. And if people were amazed at their power and working, let them perceive from them how much more powerful is the one who formed them. For from the greatness and beauty of created things comes a corresponding perception of their creator. Now notice that the evidence of God, to which this scriptural passage points, consists of phenomena and processes that are perfectly natural. Fire, wind, swift air, the circle of the stars, turbulent water, and the lights and the luminaries of heaven. Medieval theologians distinguish two ways in which God acts in the world. He can act directly in a supernatural manner, for example, turning water into wine, or he can accomplish his will through natural causes and processes, which in the terminology of theology are called secondary causes. It has always been the Catholic view, the Christian view, that God ordinarily acts in the latter way. In the words of the scholastic theologian Francisco Suarez, God does not interfere directly with the natural order where secondary causes suffice to produce the intended effect. This principle was important for the founding of science, for it implied that when confronted by some puzzling event or new phenomenon, we should look first for natural explanations. Superstitious people tend to see the supernatural in every unusual or strange event. But this was severely criticized by the great medieval theologian and scientist Nicole Orem. In explaining the marvels of nature, he said, quote, "There is no reason to take recourse to the heavens or to demons or to our glorious God, as if he would produce these effects directly, any more than he directly produces those effects whose natural causes we believe are well known to us." Another great medieval theologian and scientist, Jean Buridan, said that when confronted by new phenomena, we should seek, quote, "appropriate natural causes." That's why the Catholic Church does not declare a miracle to be worthy of belief until it has excluded the likelihood of natural explanations. So this brings us back to the crucial theological distinction between what theologians call primary and secondary causality. I think the failure to grasp this distinction is one of the main reasons why some people see a conflict between science and religion. I think this distinction is most simply explained by an analogy and by using the terms vertical and horizontal cause rather than primary and secondary cause. So the analogy is to a play or a novel. Consider the play Hamlet. You'll recall that in the play, the character Hamlet stabs the character Polonius through a curtain and kills him. So I want to ask a question. In fact, I want to take a vote. How many of you think that Polonius died because Hamlet stabbed him through a curtain? Raise your hands if you. You should all have your hands up. I just told you that's what's in the play. Now, how many of you, on the other hand, think that Polonius died because Shakespeare wrote the play that way? I gave this talk in Chicago, and I said, "This is Chicago. Vote twice. You should vote. You should vote twice because obviously they're both causes of Polonius's death, but they're causes of a different sort." Hamlet stabbing Polonius is the cause within the plot of the play. You might call that the horizontal cause. Shakespeare is the cause of the whole play. He's the cause of the fact that there is a play, that there are characters, Hamlet and Polonius, that Hamlet stabbed Polonius, that stabbing caused Polonius to die. The whole works. He is the vertical cause. By analogy, the natural causes within the plot of the universe, that scientists and really everybody studies, are horizontal causes, and in the language of theology, secondary causes. Whereas God, as the author of nature, the author of the universe, is the vertical, or theology, the primary cause. The analogy makes clear just how silly it is to treat evolution and creation as alternative explanations. Did this species come into existence through some natural process, like evolution? Or because God wrote the script of the universe that way? Both. Now, this also makes clear why scientific materialists are wrong to think that we believe without evidence. For materialists, evidence means either directly observing something with our senses or inferring its existence from something that we observe. The way we observe a compass needle move, and we infer that there's a magnetic field. Now, obviously, God cannot be seen in either of these ways because he's not a part of nature. He's not a cause within nature, something within nature that can be sensed. Nor is he a natural cause, nor is he a cause within nature. He's not a force of nature. And yet, he is a cause. The ultimate cause. He is not a cause within nature. He is the cause of nature. Nature thus gives evidence of God in the same way that a novel or a play gives evidence of its author, even if the author does not make an appearance within the plot. So let me return to the materialist historical critique of religion. The idea that Christianity and the Catholic Church in particular opposed science and tried to hold it back is called by historians of science the conflict thesis. It's completely rejected by modern historians of science as a myth that was largely arose in the 19th century. The idea that science was born in conflict with religion, that there were two warring camps, the scientific camp and the religious camp, is a projection onto the past of, well, what may be a modern reality. But in the first several centuries of modern science, the scientific camp and the religious camp were the same camp. They were the same people. Consider the great figures of the scientific revolution. The century of the scientific revolution was the 1600s. And just before that, Copernicus in the 1500s really sparked the whole thing. In that, who are the great founders of modern science? Copernicus, who was an official of the Catholic Church. Kepler, who you've heard of his 3 laws of planetary motion, a devout Lutheran, who wrote in one of his scientific treatises, actually one of his treatises largely consists of prayers, one of which is, I thank thee, Lord God, our Creator, that thou hast allowed me to see the beauty in thy work of creation. Galileo was a devout Catholic until the day he died. Descartes argued for the existence of an immaterial soul and God, and there's no reason to doubt his sincerity in professing himself an Orthodox Catholic, though many, generally atheists, cynically think that that was a front, but there's no reason to doubt his sincerity. Pascal was not only a genius in mathematics and physics, but he was a mystic. His life was profoundly transformed by a mystical experience, and he wrote works in defense of religious belief against radical skepticism. Boyle, the founder of modern chemistry, the first modern chemist, left a large sum of money to endow an annual lecture to combat notorious infidels. Now, infidel meant meaning skeptics, atheists, non-Christians in general. Newton, the greatest of them all, spent as much time in scriptural and theological study as he did on mathematics and physics. And this was true well past the 17th century. The 2 greatest physicists of the 19th century, by all accounts, James Clerk Maxwell and Michael Faraday, were deeply devout Protestants, even by the higher standards of those days. Moreover, the scientific revolution did not spring from thin air. Its foundations were laid in the universities of medieval Europe, as has been strongly emphasized by the distinguished historian of science Edward Grant, who was not a Catholic, I should say. It was in those medieval universities that for the first time in human history, science was taught on a continuous basis from generation to generation by a stable community of scholars. It was the first time, as Edward Grant said, that science was institutionalized. By the end of the Middle Ages, there were about 100 universities in Europe, and they produced tens of thousands of graduates who had been introduced by them to scientific questions and scientific ideas, and from whose ranks scientific talent could emerge. The scientific community and the scientific public created by those medieval universities, which of course were Catholic institutions originally, were the soil in which the seeds of the scientific revolution germinated. Now, a little known fact, and I want to race through this a little bit quickly so I have time to talk about physics, though I'm not sure I will have time. A dramatic and little known fact that illustrates the positive role of the Catholic Church in the history of science is the large number of Catholic priests who made major discoveries. I'll only mention a few, and I'm going to skip the Middle Ages. So, in the 17th century, there's Stenson, Mersenne, Scheiner, Riccioli, Grimaldi, Castelli, and Cavalieri. So I won't talk about all of them. Stenson's a very interesting figure. He was a Danish Lutheran. He was the greatest anatomist of his time. If you studied medicine, you've heard of several parts of the human body named after him. But he's even more important scientifically for being really the founder of the science of geology, because he's the one who first understood and developed the correct theory of the origin of sedimentary rock and of fossils. He's often listed first in histories of geology among the founders of the science. There's a Google Doodle that came out some years ago on his birthday showing strata, showing sedimentary rock, and you won't be able to see it from where you're sitting, but little fossils embedded in them. So He eventually became a Catholic, became a priest, was made a bishop, and was noted for his asceticism and concern for the poor, and Pope John Paul II beatified him, I believe, in 1988. So it was Blessed Nicholas Steno. Marin Mersenne, I'll speed up a little bit. There's so much I'd like to say about these characters. Mersenne was a friar of the Mennonite order. He made important contributions to acoustics, to the theory and design of reflecting telescopes. But perhaps his most important contribution was that he was a center, a hub of communication among scientists in his day. In those days, they didn't have scientific conferences, publication, journals, the internet. How did scientists learn about each other's work? Is largely through correspondence, and he was a central nexus of correspondence. It was in his religious house that many of the great scientists of the age met each other, such as, for example, Descartes, and I think Pascal, and so on. So he is called by the Dictionary of Scientific Biography one of the architects of the European scientific community. Christoph Scheiner was one of 4 people who discovered sunspots with telescopes independently of each other. Here's an actual drawing of him in his observatory, and here's a page from his treatise on sunspots. Riccioli is an interesting fellow. He is important in astronomy. He was an important astronomer of his time. He made one of the first star catalogs, for example. He perfected instruments for the accurate measurement of time. He was the first person to measure the acceleration of gravity accurately. But I think it only became known within the last year or two. There was an article in Physics Today that pointed out that how many people have heard of the Coriolis effect, if you've studied physics? Very important effect in physics. It's actually what causes hurricanes and things to spiral around. It was not discovered first by Coriolis in the 1800s. It was discovered first by Riccioli in the 1600s. Grimaldi, another Jesuit scientist. If you're a physicist, you will have spent time as in your freshman physics course, or if you're in graduate school, in your graduate textbooks, on something called diffraction. A central, very important phenomenon in physics. It was discovered in the 1600s by Riccioli, who's actually named it diffraction. Here are some diffraction effects. The colored bands you see on DVDs and CDs are a diffraction phenomenon. So this is, again, let's skip Castelli, though he's an interesting person. Cavalieri was one of the people who was a forerunner, who helped lead up to the development of calculus. Calculus was developed, the people who are credited with developing calculus independently of each other were Newton and Leibniz. Leibniz himself paid tribute to the work of Cavalieri, as you see. Spallanzani was one of the greatest biologists of the 18th century. He did too many things to list them all. René Just Oey was the founder of crystallography. All of these are priests. The first asteroid discovered was by an Italian priest, astronomer, Giuseppe Piazzi. He called it Ceres. There's a picture of from the Hubble Space Telescope. In 2015, NASA sent a satellite around Ceres, and these are pictures from the satellite. Ceres is actually also the largest asteroid, and it's so large that its gravity crushes it into the shape of a sphere. So actually, recently it was reclassified as a dwarf planet. And Pluto, as you may have heard, was demoted from being a planet to being a dwarf planet. So Ceres actually has the same status as Pluto, discovered by Piazzi. Secchi was one of the founders of modern astrophysics. Anyone in astrophysics has heard of him. He pioneered the use of spectroscopy to study the stars and the sun. And our current, or astronomers' current classification of stars is based on that developed by Secchi, a Jesuit astronomer. He did some of his groundbreaking work using an observatory that he had moved to the roof of the beautiful church of Sant'Ignazio in Rome, though it's not there any longer. I'll skip Bolzano, very important in the history of mathematics and logic, a Czech priest. Gregor Mendel, the founder of genetics. For Notre Dame fans, a professor at Notre Dame in the early 20th century developed the first synthetic rubber, neoprene. And last but not least is Georges Lemaitre. Georges Lemaitre, or as some people call him Lemaitre, he was a Belgian priest, an astrophysicist, actually a theoretical physicist, not an a theoretical physicist, who really is the founder of the Big Bang Theory, which is an interesting story in itself. And here he is chatting with Einstein at a conference in California. How many people know that the Big Bang Theory, not the TV show, but the Big Bang Theory, the central pillar of our understanding of the universe, was proposed by a Catholic priest who was and scientist? So I think I've used up most of my time, but let me see if I can get some physics in here. Though physics is not everybody's cup of tea, so maybe it's just as well that I don't go into too much physics. The thesis of my book, Modern Physics and Ancient Faith, which I urge you all to rush out and buy, and I urge the Catholic Information Center to put in the shelves so that you may buy it here, was that actually in the 20th century, many major, or several, I talk about 5, major discoveries or discoveries, let's say, actually made our picture of the universe and of our place in it line up a little better with the Christian and Jewish and Christian view of things than with the atheist and materialist view. I can't talk about all of them. I'll just mention a few. One is the fact that the universe had a beginning. That was taught by Christians and Jews for more than 2 millennia. It was scoffed at by ancient pagans. Aristotle believed the universe had existed for infinite time, had no beginning. So did Plato, actually. In fact, all of the pagan philosophers of ancient Greece believed in a past eternal universe. And in modern times, atheists have tended to prefer that view also. And if you were alive around the year 1900, it seemed that the scientific evidence was pointing in favor of a universe that had no beginning. And the idea of a beginning was more and more seen by scientists as a relic of religious mythology. Until Einstein's theory of general relativity came along, and people like Georges Lemaitre and others pointed out that the equations of Einstein's theory of gravity allowed the universe to have a beginning and to be expanding. It was Lemaitre who first understood that space itself is expanding, and he proposed the Big Bang Theory. And now we know that there was a Big Bang about 14 billion years ago. Not necessarily the beginning of the universe, though in the standard cosmology it was. But even if it wasn't the beginning of the universe, maybe something pre-existed before, there are strong theoretical arguments suggesting that the universe had a beginning in time. Another development is the discovery of what are sometimes called entropic coincidences. Atheists are fond of saying that the more we understand about the universe, the more pointless it seems, and the more we seem just like a cosmic accident, a fluke. I think Bertrand Russell said that human beings are an accident in a backwater of the universe. But now we realize that, and something that sort of lends credibility to this is how big the universe is. Many atheists will say, why, if there's a God, and if we're important in the scheme of things, did God create all of that useless space out there? 10 billion light years, 100 billion galaxies just in the part we can see. All that empty space. Why couldn't he have created a cozy little cosmos? More on a human scale. If we're important, why not something on a human scale? Well, anyway, I'll get to that in a second. The laws of what physicists have more and more come to appreciate in the last 30 years is that there are many features of the laws of physics as we now know them that are propitious, are favorable, or in fact make possible the existence of life in the universe. If you take the laws of physics as we know them and you were to alter, at least in thought, if you would imagine what would things have been like if certain constants were slightly different or certain features were slightly different, you would find that in many cases, even slight alterations of the laws would have radically changed the way the universe is in such a way as to make life impossible. And this is now admitted. It was fought against, this idea was actually fought against tooth and nail by many physicists even 20 years ago. Now it's generally admitted. Stephen Hawking and others, Stephen Weinberg, atheist scientists, cheerfully admit this. That suggests that perhaps the laws of physics were crafted in such a way as to make life possible. I should say, I won't give examples unless you ask me. In my book, I actually go through in great length and detail and carefully 11 examples, though there are many more. Now, there's a way of explaining some of these features of the laws of physics and why they're propitious for, or advantageous for life. It's called the multiverse idea. And if you want to ask me in the Q&A or by email, I'll be happy to talk about it. I talk about it in my book. Just take one example, the size of the universe, which troubles people. Pascal himself said, the silence of the infinite spaces frightens me, he says. If you want, it takes billions of years for life to appear, if it's to appear in accordance with the laws of physics as we know them. It took billions of years, first of all, for the chemicals which we're made of to be forged, to be synthesized in the interiors of stars, which then blow up and spew these elements out into space where they can condense to become planets and people and so on. So it took billions of years to have the chemicals there, then billions of years further of biological evolution on the planet to produce life like us. Now, if you want a universe that's going to last billions of years, it has to get to a size of billions of light years across if laws of Einstein's theory of gravity holds. If you wanted a universe, suppose you say, well, God could not just make a universe the size of North America, or maybe the Holy Land or something. Let's say North America, plenty of space for people to romp around. It would have lasted 1/100th of a second. Even a universe the size of the solar system, which is vast compared to human scales, would have lasted only for a matter of hours or days. You need a universe billions of light years that gets to be of the vast size ours is, if you're going to have time for life to appear. So even the vastness of the universe. I think I will stop here because I've spoken for 49 minutes, and I have a lot more on physics. I will say that one of the things we're becoming increasingly aware of in the 20th century, maybe I can just show a quote, is how profound and sophisticated the laws of physics are. They're based on very deep mathematical ideas. I'll give you an example. Kepler's laws of planetary motion, beautiful mathematical laws. You could explain those to an intelligent sixth grader. But they're based on deeper underlying laws. Newton's laws of gravity and mechanics. To understand Newton's laws, you have to actually know calculus. So you're talking about maybe a high school senior college student. But Newton's laws of gravity, law of gravity is based on deeper laws, which is Einstein's theory of gravity. Einstein's theory of gravity uses non-Euclidean four-dimensional space-time, curved space-time. Okay? And so you learn about that typically in graduate school, very sophisticated mathematics. But now it's believed by many, the smartest people, that Einstein's theory of gravity is actually based on, well, everyone in physics believes it's based on something deeper. And that what many of the smartest people believe is that deep too. Hermann Weyl, one of the great mathematicians and mathematical physicists of the 20th century, said, many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult today for the knowing person to approach God from history, from the spiritual side of the world, and from morals. For there we encounter the suffering and evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony which is in conformity with sublime reason. I guess I'll stop there.
Okay, so we have time for several questions. So if you have one, please just raise your hand. I'll bring the mic over to you. And just be sure to hold it fairly close to your mouth so that we can capture the audience. Thank you.
Professor Barr, you touched on this a little bit in terms of scientific resistance to the Big Bang Theory, and I think there was tension between that and the steady state theory, which would say that the universe had no age and it would go on forever. Are we seeing kind of a replay of that debate with the multiverse theories, or is that too simplistic?
Slightly too simplistic. There was resistance to the idea of a Big Bang. By the way, one of the most enthusiastic believers in the Big Bang Theory is Pope Pius XII. In a famous address in 1951, I think it was, to the Pontifical Academy of Sciences, he really celebrated the Big Bang Theory as showing that the universe had a beginning, and as Christians and Jews had always believed. But the resistance to the Big Bang Theory was partly caused by a philosophical discomfort with the idea that the universe had a beginning, which smelled like a creation event. Now that's a story unto itself. But there were also good physics reasons for the initial skepticism about the Big Bang. Very good one, which is that the initial estimates, the first evidence that Lemaitre and others used was the fact that the distant galaxies are receding from the Earth, as if the universe is expanding. But but people miscalculated the distance of those galaxies from the Earth, and because of that, when you traced back to the time when this explosion took place, they got a figure of something like 2 billion years. The universe is about 2 billion years old. The trouble with that is it was known from radioactive dating and other things that the Earth and from other arguments that the Earth and stars were more than 4 billion years old. So you can't have a universe younger than its things in it. But then later that mistake was corrected, and that reduced a lot of the resistance to the Big Bang. So in the final analysis, in science, people do have prejudices in physics. There's no question, and they affect maybe how long it takes a theory to be accepted. But in the long run, the data decides. It may be a very long run. It could be even centuries. But the data eventually decides, and the data became overwhelming in the 60s, 70s, 80s, and now everybody accepts the Big Bang Theory without any qualms. So multiverse is a more tricky thing. The trouble with the idea of the multiverse is, is the more conservative version of the idea. It is one universe, but it is extraordinarily vast, and that actually we have strong reason to believe, much bigger than the part we can see. And the idea of the multiverse is that and this one universe has one set of fundamental laws. But those laws have a flexibility built into them, such that certain quantities, which we used to think, or traditionally thought were constants of nature, like the mass of the electron, say, or the strength of certain forces, actually can vary from place to place. And so the idea is that some of these features, some of these things have to have just the right values, as I said, to have life. And so the multiverse idea is that, well, these things take all sorts of values throughout this multiverse, and there's bound to be a place where they all have the values just right for life. Okay? And some people, now here it's religious people that scoff at the multiverse idea. That is, religious people in general population say this is just an idea cooked up by atheists to get around the obvious conclusion that there's a God. That's simplistic, because actually the vast majority of people in my field, in fundamental physics, hate the idea of the multiverse, including the vast majority of atheist physicists hate it. And the reason is that it's almost certainly an untestable hypothesis. So it cuts across. I actually think there's very strong reasons to believe that we may live in some kind of multiverse, but many atheists hate the idea, passionately so. I would say that it's not a simple us versus them. Yeah.
Can I take the bait and take that one step further? I mean, you're really you're leading this horse reluctantly to the reason that I came here, which is because I read your things in First Things. I was very surprised, to hear your support of the multiverse that I read in First Things in a comment somewhere, and that's why I'm here. Like, what?
That's what
I'm not against it
too.
I mean, I was a physics major at Duke, and so I've got some of this behind me, but it's beyond me to be able to evaluate the multiverse theory as viable and scientific versus what you said.
It's not a theory, it's really a scenario. And I don't support it. I simply take it seriously as a possibility.
And why?
Okay. Because what you need for a multiverse is two things. Because we know when we look at the part of the universe we can see, which is we call the observable universe, you can't see farther than a certain distance, because anything farther than that, the light has not had time to get to us since the Big Bang, and so we'll never see it. So the part we can see has to be a small part of the whole universe, but the part we can see, all these constants are constant. The mass of the electron is the same throughout the observable universe. So if you're going to have all these variations taking place, they have to be in a much larger universe. That part of we have very strong theoretical reasons to believe that the universe is way bigger than the observable part. The other thing you need is to have flexibility built into the laws that allow these parameters to take different values in different places. And there is some something like that is likely to be true, even if you take something much more simple than, say, superstring theory. Take grand unified theories, which is what I have done a lot of work on. You take your simplest supersymmetric grand unified theory, they actually do allow certain things to take different values in different parts of the universe. So that's not far-fetched at all. And in fact, in superstring theory, there's strong arguments, even though we may never be able to test it, there's strong theoretical arguments that may be the ultimate theory of physics. Superstring theory does seem to have the feature that it has very large, that kind of flexibility built into it. That's why. So there are theoretical reasons to take it seriously, that's all I'm saying.
Are there any experimental
dimensions
of this at all?
The reason a lot of people believe in superstring theory is it is the only way people know, after almost a century, of building a consistent theory that incorporates both the principles of quantum mechanics and the principles of general relativity, Einstein's theory of gravity. And we have and it's the only way of putting those together that anyone has been able to come up with in many decades. And that's why a lot of people think it may be the only way to do it, which means it has to be right, because we know that general relativity and quantum mechanics are right. And so the arguments are theoretical. And so indirectly, yes, they rest on experiment, but can we test the multiverse idea? No, probably not.
All right, we have time for one more quick question, and I will let your brother ask it.
My brother. He saved me from atheism when I was 10.
By making the point that why is there something versus nothing? So even this multiverse model that you discussed, this scenario, would still be the one universe that was created or suddenly emerged. What do you think of the current effort by scientists to posit that something can come from nothing?
Right. That's a long thing, but I'll give a short answer. Some physicists, Hawking, for instance, the late Stephen Hawking, and some lesser people, have said, maybe the universe might have begun with what's called a quantum fluctuation. That's actually a beautiful idea. And again, I think it's very plausible. But whether we'll ever know is not clear. And so what Stephen Hawking would say is, quantum gravity shows you that you can have universes just sort of popping into existence, okay? And therefore we don't need God. Well, the answer to that, first of all, who ordained that there would be something called quantum gravity? Why is there quantum gravity? That doesn't have to be. But even so, there really is a much more fundamental problem with Hawking's idea, which Hawking himself once understood in his very famous book, A Brief History of Time. He said, back then, when he understood, he said, all that physics gives you is a set of rules and equations. What is it that breathes fire into those equations to make a universe for them to describe? And this is continuing the quote. The usual approach of science, and this is the only approach we know in physics, the usual approach of science of constructing a mathematical model cannot explain why there is a universe for that model to describe. And before this afternoon, my brother gave me a very good analogy. They're the rules of baseball. But just having a book of the rules of baseball does not explain why there's actually people playing baseball, why there are baseball games that are described by those rules. And just having equations of physics, as Hawking understood, does not answer the question of why there's an actual universe described by those equations. What I like to say is, the answer to Leibniz's famous question, why is there something rather than nothing? The answer is God. Not because God is a physical mechanism, as Hawking said, touching the blue, touch paper, a match to the fuse that caused the Big Bang. People who think that God created the universe by sort of lighting a fuse, that's putting God down on the level of a natural cause. God confers reality on the world. That's what creation is, according to Thomas Aquinas. He makes the world real. He's the one that is responsible for the fact that this isn't a fictitious world or a hypothetical world or a possible world. It's an actual, really existing world. And because God confers existence on it as the cause of being. And that an equation cannot do. Okay?